Next up, we're going to do a changing order of integration problem. So all I've done is I've written the answer for our last problem right here, save a little bit of time. And then we're switching the order of integration from dz, dy, dx, which this would be very difficult to compute, to dy, dz, dx, thinking that that might be a little bit easier. And I wrote down these inequalities the same way I did when we did that triangular wedge problem. So this integrals bounds tells us that z falls between those two values. The bounds for y tell us that y falls between these values, and the bounds for x tell us that x falls between these values. And I just need to fill in the new order of integration. So the first one is y, and I know that that means it can depend on z and x. So I kind of look at the information I had before and find something that depends on x, y, and z. So I had x squared plus y squared is less than or equal to z. And if I want to change this to bounds for y, I have to notice that this is a circle. And so it's not enough to say, okay, y is less than or equal to square root z minus x squared, because that would sort of change. What I had before was a circle with radius z, and I filled in the whole thing. If I just do y is less than that, then I take a semicircle and it kind of like doesn't exist down here. So this single inequality actually tells us two things about y. It's less than square root z minus x squared, but it's also above the negative branch. Z is greater than negative root z minus x squared. All right. And then I'm looking for the bounds for z next. So I'm going to go and look for something that uses z. There we go. And so before I had z is less than or equal to 3 minus 2x. I don't have to change anything about that. That tells me an upper bound for z in terms of x. So that's nice. And then I have to figure out something else that tells me about bounds for z. And what's going to help me is to remember that my outer bounds are established by the projection of the like 3D surface down into, in this case, the ZX plane. Usually we think about the XY plane, which happens when the widest part of the surface occurs, or when the upper and lower bounds hit each other. So I'm going to look at, when does root z minus x squared equal negative root z minus x squared? I could say a number is only equal to its negative if it's 0. So I could say, well, that means I must have z minus x squared equals 0. Or I could say, okay, that's 2 root z minus x squared equals 0 by adding that to both sides. Or z minus x squared equals 0 when I cancel out the 2 and the square root. In either case, it takes me to the solution, z equals x squared. I showed both these things because you all have different ways that you like to do algebra. Any way that gets you from here to here is fine. And so I only have a lower bound. I know that the x squared goes there. But if I was at all unsure, I could go ahead and plot this. I could say there's x, there's z. X squared looks like this. And 3 minus 2x starts here and goes like that. Oops. Keeps going on both sides. So it must be that the top one is the line and the lower one is the parabola, because that's just how it matches the picture. Oh, and sorry, this right here would kind of tell us that shadow of our surface down into that XZ plane. So So that's cool. Let's see, sorry, I want to label everything. There's first one was star. Okay. And now we just have to fill in our x bounds. Well, I'm just going to actually put it right here instead. So I was told before that x is between -3 and 1. Nothing that I did up to this point changed that fact. So x is still between -3 and 1. I'm so sad I erased that picture. Okay. So -3 and 1 is also going to be where this line, z equals 3 minus 2x, hits this parabola z equals x squared. So that's just something that works from the geometry of the problem, because we used all these facts before to find the bounds for x. But if you didn't know what to do from this point, you could go ahead and solve 3 minus 2x equals x squared. You'll get x squared plus 2x minus 3 equals 0. That's x plus 3 times x minus 1 equals 0. That's x equals 1 minus 3. So minus 3 less than or equal to x less than or equal to 1.